All right, we're on the last one here now. This is number 14. This is that Egyptian formula problem. Remember how it works. We match up opposite sides of the quadrilateral, and we have a couple of quadrilaterals here. Let's kind of, we're getting a lot of color going on this thing. We've got this one. That's quadrilateral ABCD. In blue there, that's a rectangle. We recognize that. And we see that it's got side lengths of 8, 10, 8, 10. And the other one we've got here is this one. Looks like a parallelogram. Also 8, 10, 8, 10. So that's A, B, E, F. All right, so we have these two quadrilaterals. Right now, the whole thing with this Egyptian formula is we know sometimes it works, sometimes it doesn't. So we need to demonstrate when it works, when it doesn't. And so to do that, let's deal with this one first. Oops. So in ABCD, using the Egyptian formula, opposite sides go together. Remember, we label around A, B, C, D. All right, so consecutively. So the area equals 1/4, 10 plus 10, and times 8 plus 8. All right, so there we have 100. We have 20, and we have 16, and 20 times 16, and 1/4 of that, and that equals, so we have times 20 times 16, so this equals 80 units squared for the rectangle. All right, now if we just do the regular length times width rectangle to verify that, it's easy to use the rectangle because you can also visually verify it. You could count and find that there are 80 units in there. All right, so now I've done two things. I've used the Egyptian formula to show that we got 80 units squared, and I've used a regular formula, length times width for rectangle, and shown and confirmed that we get 80 units squared. Now let's do the red one. All right, first let's do the Egyptian one. So this is for A, B, E, F. So I have the area equals 1/4 times. Again, we're going to have 10 plus 10 and 8 plus 8. So that's the same work we had over here. So it's going to show that using the Egyptian formula, the Egyptians are saying that it is 80 units squared. All right. Not so fast. Let's see if we can find another way to calculate this. So that's what we'll do. I'm going to turn this into a rectangle. I'm going to cut off this triangle here that I'm highlighting in yellow. I'm going to cut it off right here. And I'm going to move it over here to a congruent space. Right there. All right. So now, here's my new rectangle. Our new quadrilateral. We cut that triangle off, put it over here like this. Now we can have a much better basis for comparison. I've outlined it in black. All right, so we know that this is still 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can see that's correct. But this 10, that was the diagonal one, the oblique line, 1, 2, 3, 4, 5, 6, 7, 8. Now that we have this vertical line, you can see it's really 8 there. So now I've got an 8 by 8 square. So this parallelogram can be rearranged into an 8 by 8 square, which makes it very easy to determine what the accurate area is. And 8 squared equals 64. So we're showing here that on the rectangle, the Egyptian formula gave us the same formula as our regular rectangle area formula. But on the other figure, once we rearranged it and turned it into a square, we discovered that the Egyptian formula gave us the 80 units squared, but in actual fact, it's 64 units squared. So use the figure to show that the Egyptian formula does not always work correctly. We've just done that. All right, and you can do that the same way on the test. This is a good way to kind of use a little common sense to try and figure out some of these types of problems like this. So hopefully you have a better understanding of that now. And we've reached the end. You have a geometric day, and we'll see you on Monday for the test.